Okay, welcome everyone. I do see that more are joining, but we'll go ahead and get started. We're after the top of the hour here on the East Coast in the US, so we'll go ahead and get started. I'd like to welcome everybody. This is GL's August webinar, and we try to do one every month. It's part of our webinar series that is ongoing. If you haven't joined us before, we welcome you for the first time. If you have joined us before, you kind of understand how we do this. We typically will pick a topic every month and get a couple fellows together, get a couple engineers together, and just discuss it, talk about the products that GL has in relation to that topic, and just have a 1 hour little session on that. So the topic this month is advanced features of PacketScan for all IP protocol monitoring. So we're going to be talking about GL's PacketScan product and its variants, as well as another product that you may have heard of called NetSurveyorWEB. So it's an exciting topic for us today. My name is Matt. I'm joined by Vikram, Sanjeev, and Sanjeev. Sanjeev K will be sort of administering the webinar and will be monitoring questions that you may have throughout the webinar. So I would encourage you to type in some questions if you have one or two questions. You can type them into your GoToWebinar menu bar there, and Sanjeev will be watching those and we'll be collecting them, and we plan to have plenty of time toward the end of the hour to have sort of an open forum for question and answer. One other note before we get started, we are recording the webinar, so we plan, as we do with all of our webinars, to post the recording on our website in the coming days. So again, thank you, and we'll go ahead and get started here. So if you're not familiar with GL, I'd like to give you just a quick overview. GL Communications is a company that is headquartered in Gaithersburg, Maryland in the United States. We have other offices in China and India, and we have sales representatives throughout the world. We've been around for a while. We were founded in 1986, and we specialize in basically a couple things. We create and manufacture, develop, and market test and measurement equipment to telecom industries. So we have many products. A lot of them are based generally PC-based products, very easy to use, research and lab developments in the field and so forth. We also have a division of our company that does engineering consulting services, and typically we do that for local, state, and some federal government agencies. So that's who we are. For the webinar today, I'd like to just go over the agenda very quickly here. We're going to be talking about PacketScan, and sometimes we refer to that as our probe. So it's a capture probe that can be deployed and monitor IP links traffic. So fundamentally, it's a non-intrusive capture device or capture application to monitor all IP traffic. It has the ability to do protocol decodes, and it specializes in voice codec support and organizing calls, voice calls, so that they're easy to review, analyze, and take action on. You'll see how PacketScan has the ability to organize frames, like I was mentioning, into very logical manner. So we typically organize the flood of frames that we're capturing into calls, and then or sessions, and then you can take action on that. So PacketScan can give you sort of a gross level of your network, and we'll talk about that a little bit on how it can be monitoring the network at a high level, giving you sort of a bandwidth statistics, number of calls seen in the last hour statistics, things of that nature. Or we can get into a very detailed analysis of a single call, where you can listen to that call or look at the oscilloscope of that call or look at any in-band digits that were detected during that call. And we'll show you some of those capabilities, some of those algorithms that we have built into the PacketScan and NetSurveyorWEB. So outside of PacketScan, it's sort of a complementary offering that we have. We call that NetSurveyorWEB. So we will be talking about NetSurveyorWEB. And basically, NetSurveyorWEB is a database that we have, and so that these PacketScan probes can feed the captured data to it, and they can be stored for archiving and for data mining. So once the data is in the database, once we have the information captured at the probe level, we can store all of that in our NetSurveyorWEB product, and that has a very powerful powerful capabilities to mine data, look for trends in the network, identify calls of interest that you may have, trends of interest that you have identified. So this NetSurveyorWEB we will get into, we'll show you some of the capabilities of that. We'll talk a little bit about some of the deployments we have of both of these products. So to get started, we'll jump right into the PacketScan. And as an intro, I just would like to say that PacketScan, excuse me, at its basic level is an application. So it's a piece of software that we have, and it can be installed on a Windows-based computer or host PC, I like to call it. And that PC can be a laptop, it can be a rack-mounted server PC with a lot of horsepower. It can be a tablet PC, it can be whatever, PC generally running Windows, okay? So we support the latest and greatest of Windows and PC capabilities there. And PacketScan at its fundamental level is just an application that gets installed on that host PC. And it utilizes the integrated network interface card. So with it at its basic level, you can install it on a PC of choosing. A network interface card is present there. You can start capturing and analyzing IP traffic just with that. That's typically used for a single 1 gig interface with low or medium volumes of traffic. That's sufficient. If we need to get into multiple interfaces or higher bandwidth interfaces, additional hardware is required, and we call that offering the PacketScanHD, as you can see here on the top right. So with a higher bandwidth requirements, with higher density interfaces, 10 gigs, and multiple 1 gigs, 40 gig, 100 gig, we require some additional hardware to be installed on generally server grade PCs, or we can install them on portable as well. But additional hardware card is required to interface to those networks. And that allows us to have a lot more capability, and so a lot more hardware filtering capability and so forth. So this PacketScanHD is sort of our, just to clarify, it's just our higher density PacketScan offering. All of the features of PacketScan, if it exists in just a single host PC with an integrated NIC, are available in the PacketScanHD and vice versa. The only thing PacketScanHD does is allows you to interface at very higher speed interfaces and allows you to analyze at a higher bandwidth. Okay, so that's why I wanted to clarify that up front here. We'll talk about a little bit of both of those throughout the presentation. NetSurveyorWEB on the bottom right typically just requires a PC, and we install some software, a database, and you're off and running. Okay. So to expand a little bit on the PacketScanHD offering that we have, it requires higher horsepower network interface cards. So the interface at your network may be 10 gig interface, or even higher than that, 40 and 100 gig. So we have the ability to install one of our cards in a PC, a server, and give you access to those interfaces. So that's what we would require, an additional piece of hardware here that we're showing in the pictures. So that can be deployed, as I'm showing on the far left here, in a sort of portable, we'll call this like a briefcase type PC. These are high horsepower PCs that we can install PCI Express cards in, and we can install one of these interface cards in it. And you have somewhat of a portable environment there that you can carry around to different locations. If your deployment is static in nature, typically we will put those in a rack-mounted server grade PC. So this slide here kind of addresses the PacketScan variants, PacketScan basic version versus the PacketScan HD, and how just one metrics here on how we're counting calls as far as what we can support within our application. So with the general PacketScan All-IP product, we can monitor, record, extract voice on 2,000 calls simultaneously. Now, PacketScan HD, you can see that increases to 20,000 calls on a 4x1 gig interface card. So it's just a slide to show you that at higher speeds and at higher density applications, the PacketScan HD is required. At the bottom there, the 30,000 calls is getting into some sort of application limit, honestly. So at some of these very high speed, 40, 100 gigs, we can use the built-in filtering within that hardware card, and then filter down so that the application can handle and manage those calls for you. So this is showing a little bit of the differences in the variance between the PacketScan and the PacketScan HD. This slide here is just a graphical depiction of how PacketScan is generally deployed. In an all-IP network, like we're showing here on the left side, where IP may go all the way to the end user per se, we can deploy PacketScan in that sort of environment, and that's generally an enterprise. Call centers, a lot of times call and contact centers have this full IP all the way to the end user. So we can deploy PacketScan at that location. Top middle of the screen, we're showing more of a hybrid network, I'll call it, and where a gateway present or router present network, where a transition happens between like TDM and IP. So the PacketScan can be deployed in these locations as well, where we see protocols such as SIGTRAN, Megaco, and MGCP, and SIP, of course. On the right-hand side, we're showing a wireless IP environment. So that now we're typically talking about GSM, LTE, UMTS over IP networks, and PacketScan can be deployed there. So PacketScan can be deployed toward the edge of your network or in the core of your network. And where IP is present, we can just deploy PacketScan, and we can start monitoring and capturing, and you'll get all the capabilities of PacketScan, which we're going to be showing you here as we progress. One other thing to mention on this screen, the centralized database, or what we're calling the NetSurveyorWEB, is being shown, and all of these packet scans, these probes that are throughout a network, or if you have one or two deployed, we will show you how that data and those captures can be streamed back to this database, and then data mining and trend analysis and triggers and actions and all types of things that we're going to show you throughout this webinar are available to us at that point. So it's a very nice clean solution where we have PacketScan probes deployed at different points in the network, and then all of that data being sent back to a database. Applications. We put a slide in here to show sort of, again, to expand a little bit on the last slide on where PacketScan can be deployed, some example applications on where it is used. The top one is shows a wireless service providers, in a sense, and equipment manufacturers. So we have the ability, all of these are all IP domain networks, okay? So we're going to be looking at the voice calls throughout these IP networks. The top one's representing wireless network. The bottom one is generally, I'll call it a VoIP wireline environment. So we're talking again about some call centers, contact centers, 911 in the US, 911 call centers that are transitioning to all IP. So these types of environments, PacketScan can be very useful in these areas. Second slide devoted to applications. The top is showing you that if you're an equipment manufacturer responsible for gateways or proxies and registrars and so forth, IP phones even, PacketScan can be placed there to help you monitor traffic going in and out of those devices. And you're able to do different things, different statistics, different performance measurements can be used and extracted from PacketScan. And a unique on the bottom of the screen here, a unique environment, somewhat limited, but it shows the nature of how PacketScan can be deployed in sort of a specialized environment. We'll call this the air traffic management environment. So we're able to monitor in air traffic management. If you're familiar with that, they have a protocol called ED137, and it's a SIP-based protocol. It's a SIP variant. So we were able to very easily transition PacketScan, modified PacketScan to work in this environment. So we're able to monitor air-to-ground calls, ground-to-ground calls, and recorder calls in this environment. All of this, I should mention, quality of service metrics, quality of service statistics, MOS scores, delay measurements, all of that is one key feature of PacketScan that we'll be showing you as we move on. Okay, so I've mentioned a few of these, but we put them on the screen here just so that we can show you. This is generally a partial list, quite honestly, of what PacketScan supports on the protocols and the codec side. So with protocols, we're talking the basic SIP, SIP-Is, so forth, megacos. You can see the list here: SIGTRAN, the SS7 variants, ISDN. In the wireless domain, we're talking GSM, UMTS, and LTE. So with the traffic there, the RTP traffic, all of that is being decoded, analyzed, and so forth. Supported codec side, we support a large laundry list of codecs. I would have to say that this is probably a partial list because we're adding them, it seems like, weekly. But traditional ones, as well as higher compression ones, we're talking, you can see on the list there some wireless codecs, 3G and 4G ones, AMR, EVS, and so forth. So PacketScan is very comprehensive on the protocols and codecs supporting within it. So with that said, I think it's appropriate now. The next slides and the next few slides are going to be where we dive a little bit deeper into PacketScan, the actual software application. And my colleague Vikram will join us here, and he will present some of the features and functions of PacketScan from the software interface level. Vikram?
Okay, thank you, Matt. I hope I'm coming in clear, and I hope everybody can hear me well.
Yes.
Thank you for attending this webinar, and thank you, Matt, for the introduction. So let's dive into it and really look at PacketScan in terms of the graphical user interface. So here we show a screenshot of the main PacketScan page. If you're familiar with GL's other protocol analyzers, or if you're familiar with open source protocol analyzers like Wireshark, you're going to notice that this is very familiar. So what we have here at the top in that top pane there where it says summary view, we have packet by packet look, where on every single packet we show the relevant information related to that packet, and for instance, timestamp, protocol, source IP, destination IP, etc. So that top panel is just looking at the packet by packet level. Just like any other protocol analyzer, you can select a given packet, and in that middle pane there where we say detail view, it shows you basically the full decode of a given packet. So the packet that we have highlighted right now is a SIP packet, session initiation protocol. So it's basically setting up a voice over IP call, and that's the very first packet. It's an invite packet, as you see there highlighted. So for any packet, you can get your full decode information. And furthermore, we give you the hex dump as well at that bottom pane if you're interested in the hex dump. The one thing I really want to mention here on this slide is that everything here is customizable in terms of what you want to view. So if you want to hide a certain pane, you can do that. Like if you want to hide the hex dump panel, you can go ahead and do that. If you want to display different columns in the summary view, you can do that. So if you want to hide a certain column or if you want to add additional columns, we basically allow you to add any column, any field in that protocol. You can basically add it as a column. So it's very, very flexible, very easy to use if you're coming from a different protocol analyzer. And this is just the first look at PacketScan. In the next slide, I'll show you how we can go from the individual packet level to actual calls, analyzing actual voice over IP calls. So, actually, I'm sorry, before we do that, let me first talk about the filtering, because that's a really important advantage that our product has. Okay, so Matt did a really good job introducing our products, but I just want to hit home some things. Let's say you're tapping into a high bandwidth line. We're talking, 10 gigabits per second, or even 100 gigabits per second, and you want to see all the packets. Well, if you just have your own computer and you just tap into the line, you're going to miss a lot of packets because your standard network interface card cannot keep up. So that's why we have a hardware version of PacketScan. And so up there in the top left, you see PacketScan HD. And PacketScan HD, as Matt mentioned, has many different types of network interface cards that you can use, whether you just need 1 gigabit per second, 10 gigabits per second, or even 100 gigabits per second. We have that hardware capability. Furthermore, if you're tapping into a high density line, you're probably not interested in all the packets. For instance, let's say you're only interested in voice over IP calls, and most voice over IP calls ride over UDP. So say you want to only filter on UDP packets and you don't want to include the TCP packets. So we have a hardware filter there, which is a super fast filter because the filtering is being done at the hardware level on the network interface card. And it'll be able to, as packets at wire speed, be able to filter the packets so that only the packets you're interested pass on to the software. So that hardware filter, the advantage is that at very high data rates, it can keep up and it can show you the packets that you're interested in. After the hardware filter, we have other filters. We have a software filter. So if you do just have the software, this is the first level at which you can filter packets. It's basically at the software level now. And again, you can do the same thing. You can filter on all sorts of different things, by the way, for both the hardware and the software filter. You can filter on any sort of protocol, any sort of field in any protocol, source IP, destination IP, source port, destination port, whatever you want to filter on. And finally, the third filter here, where it says view filter, that's just what you want to view. So say you're only interested in viewing HTTP packets or something. So it'll only show you the HTTP packets. it won't show you the other packets. However, if you just do the view filter, all of the other packets are still saved. So you'll still save all the other packets. It'll only display certain packets. So so those are the three different levels at which you can filter packets, and depending on your requirement, depending on what kind of speeds you're trying to capture at, that's going to determine whether you want our hardware and software or just the software option of PacketScan. So let's move on to the next slide, where we'll get back into the GUI. So here is one of the really powerful aspects of PacketScan. PacketScan is really designed for telephony applications. So it's designed to monitor telephone calls. So if you see in that top pane all those purple lines, each of those lines is an actual phone call, an actual voice over IP call. So what PacketScan can do is it can take all the packets, the hundreds of thousands, millions of packets that you're capturing, and intelligently aggregate them into distinct calls. And then when you go one level up like that, from the individual packet level to the call level, you can analyze statistics on each individual call, or you can analyze statistics on all the calls. In the bottom left panel there, you see we're showing you the total number of active calls. So say you're active, you're tapping into some line and you're just trying to monitor all the active calls that are happening on your network. And so we can give that to you. That's just one graph. We'll show you many more graphs. In the bottom right pane, you get some summary statistics, total calls, active calls, failed calls, all that type of information. So I want to really highlight here that PacketScan is designed for telephony. That's our bread and butter, really. It's analyzing voice over IP calls and giving you all of the data that you could want on a given call. One other important feature here that I want to highlight, in the top of the screenshot, you see a green arrow, and that's actually the playback option. So there you can select any call, and if you've captured all the packets, you can play back the call. So we have the ability to play back any call, record it, save it, calculate statistics on it, which I'll talk about more on the next slide. But here we're just showing a whole bunch of summary statistics on the different calls that you can monitor. These bullets here on the right, I think we're going to get to it. Yeah, we're going to get to it on the following slide. So let's zoom in on an actual call, one individual call. So you notice that in that top pane, we've highlighted one call. And in the bottom left graph, you can see the ladder diagram for that call. So you get the timestamp, you get the entire ladder diagram describing the call setup, the call maintenance, and the call teardown of a given call. You can click on any one of those arrows and it'll give you information on that specific packet, which is shown in the bottom right panel there. So that means for any call, you can go in, you can diagnose it, you can see, was it a successful call, failed call, why was it successful, why was it failed? This gives you a lot of good information. The drop-down menu on the right here, it just goes to show you that we can filter on all sorts of different calls. If you only want to look at your failed calls, because you're getting a lot of failed calls over the last few hours or something and you're trying to figure out why, let's just look at the failed calls. So we can filter on any sort of call you want. And also the other drop-down menu to the left of that drop-down menu, we give you the option of all sorts of different protocols. So you could be monitoring SIP calls, you can be monitoring H323 calls, all sorts of different protocols. We offer, as Matt mentioned, we can filter on all those different types of calls and decode them and give you full analysis of the calls. Let's move on to the next slide. And here, what we're doing is, okay, we went from the individual packet level to the individual call level. Now let's aggregate the calls and let's get an understanding of all of the calls in terms of the distribution. So for instance, this top graph here where it says average jitter, this is a histogram. So say you have thousands of calls and you want to know, what was the average jitter on the calls? Well, you see that there's a big spike there at 16 milliseconds. So a lot of the calls had an average jitter of 16 milliseconds and so on. So we give you all sorts of histograms on the calls. This is just a great bird's eye view of what your call performance is like. If you're monitoring thousands of calls, what do you want to know? In the bottom left and the bottom right, you see that we give you the mean opinion score. So the mean opinion score is a measure of the voice quality. So we can tell you, okay, how many calls gave you good voice quality, how many of the calls gave you bad voice quality, and so on. You can see that very easily through this bottom left histogram. In the bottom right, again, it's not just the mean opinion score. We can give you histograms on basically anything. Here we're showing you packets discarded. So we see that some percentage of the packets did drop a significant number of packets, and so you can, or discard a significant number of packets. So now that if you're trying to monitor call performance at a call center, you can try to investigate what's going on here. Why are so many packets being discarded? So this is looking at all of your calls. Let's move on to the next slide, and I'll show you even more analysis that you can do. Here, we're giving you both sides of any given call. So now we've drilled back down to a single call. And in the left top pane there, you see all of the packets going one way from point A to point B. And so in the bottom left pane, you see statistics associated with that stream, with that direction. So you see the source port destination, and you see the MOS. So if you want to know just for a given direction, what's the voice quality from that direction, we can give you that statistics. And so similarly, on the right, we give you all the packets going the other way from point B to point A, and we give you all the same statistics. So this is very good if you're diagnosing problems where, one side of the conversation is coming in clean, the other side of the conversation is noisy and is experiencing poor voice quality. We can basically look both ways at the call. Just another powerful feature that PacketScan gives you. On the next slide, we're gonna show more graphs. So here, if you're monitoring voice quality, we can show you different graphs, again, on both sides of a given call. So here, the graphs on the left are graphs from the voice coming from point A to point B, and on the right is point B to point A. And so you see that we give you the R factor and we give you the mean opinion score for both ways. We make it very easy to digest, and we put in simple graphs. You can save these graphs, you can export the graphs, you can customize the graphs, you can do whatever you want to do. And again, yeah, we give you voice quality metrics, so you don't need to calculate it yourself. You don't need to feed it into some other program or write code. We give that all to you. On the next slide, we'll show you even more. Okay, so as we know, when you're making a phone call, you can dial digits in the middle of the call. Say you're talking to some voice recording and it says press 1 for this, press 2 for that. So we can monitor those dialed digits. So on the left there, you see all the in-band events on a given voice channel. So every time the user is dialing a digit, we'll record that so you can see it. So those are what's known as in-band events when you're sending signaling in the voice path. We give you all the statistics that you want on the in-band events, when they happened and what frequencies and so on. On the right, we give you all the out-of-band events. So all of the other signaling information that's happening out of band we give you all of these graphs, all of this statistics, and record all these events as well. So I hope that as you're watching this webinar, you're starting to realize just how powerful PacketScan is when it comes to monitoring calls and just the level of detail you can get into to analyze calls. On the next slide, we just have a couple more graphs to show you. So at the top graph here, we see the actual wave graph, meaning just the amplitude is a function of time, and we do it for both sides of the conversation. So the red there shows one side of the conversation. You see that the person, there's a lot of voice going from A to B initially in the first 10 seconds of the call, but then later in the call, you see that there's a lot of conversation coming from point B to going back to point A. And so we give you both sides of the conversation in the time domain as well as the frequency domain. So if you want to see the frequency components, this bottom right-hand graph there, the spectral display, gives you all the frequency components again for both directions of the call. So another powerful feature of PacketScan. But in my opinion, one of the best features of PacketScan is the ability to trigger on a certain condition and generate an alert. So if you're a human, you're monitoring, think about it, if you're monitoring a high density line like a 10 gigabits per second line or 100 gigabits per second line, there's no way a human can just sit there and look at the packets and try to find things on his or her own. They need to be alerted. And so we can trigger on certain aspects. We can basically trigger on everything. Here are just some of the examples of what we can trigger on. So for instance, maybe we want to trigger when a certain number is being dialed. Okay, so anytime that specific number is being dialed, maybe this is some surveillance operation or something, we can set a trigger. And so we set a trigger on that. Maybe we want to trigger on the voice quality. So if all of a sudden we're experiencing poor voice quality on a call, we want to generate a trigger so we can immediately diagnose the problem. So you can trigger on the mean opinion score. We can trigger on the call duration. Maybe we're want to trigger on calls that are over an hour long. We have that ability to trigger on that. From the trigger, you can take an action. So maybe the action is to just pop out an alert. So on the alerts pane of PacketScan, there's an alerts pane, and so you can actually see all the alerts popping up. We give you other options as well, like if a trigger happens, and immediately record that audio. So that's another trigger you can do. You can send an email alert. You can export the packets to a CSV file. You can export it to a packet capture file, trace file. So you can really trigger on any sort of thing and then immediately take an action, which is essential because you can't rely on a human to manually monitor a high density line. So this is a very powerful advantage of PacketScan. And we'll go now to the next slide. And here, okay, so here, I just want to focus actually on the bottom right graph. We can give you the mean opinion score in real time, basically. What we can do is you can tell us, hey, instead of calculating a mean opinion score for the whole conversation, let's calculate it in chunks. So maybe we want to sample every 10 seconds, compute a mean opinion score, then do it for another 10 seconds, sample again, compute another score, and so on. You may be interested in that because maybe initially in every single call, the voice quality is very bad, but then later on in the call, the voice quality picks up. You never know. Or maybe on a, so here in this bottom right-hand graph, we show you for both sides of the conversation, we show you the mean opinion score. So you actually see here, going from A to B, the voice quality from A to B is fluctuating quite a bit. You get pretty poor voice quality initially. It picks up and then it drops again. Whereas the other side of the conversation is just perfectly smooth, crystal clear voice quality. So you can analyze that in real time, and you can look at the mean opinion score for any given call throughout the call duration. So that's another powerful advantage that PacketScan gives you. And okay, so by now you're probably convinced that PacketScan gives you an enormous amount of capability, but you may also be thinking, okay, well, you know, there's open source free protocol analyzers out there like Wireshark. So what's the advantage of PacketScan over an open source protocol analyzer like Wireshark? So we wanted to make that crystal clear. On this slide and the next slide, we highlight some of the advantages. There's plenty more. We analyze some of the advantages that PacketScan gives you over Wireshark. So the first one there is that we provide voice quality metrics like the mean opinion score and the R factor. Wireshark, on any given call, it will not compute any of that for you. So that means you'd have to go in and manually try to compute that yourself. It's a big hassle. We give that all to you, and we showed you that in the previous slides on the graphs. So that's very good. We give you voice quality. This second bullet, Sanjeev Jigajini will talk more about this in a few slides. It's a huge advantage. It's the ability that you can have PacketScan automatically send back data to a central database. So let's say you have PacketScan deployed in several locations in a network. You can have each of those PacketScans as a probe, like Matt was saying. You can have them send the data back to a central database so that as a user, you can just log into the central database and you can see everything from there. Sanjeev will talk more about that. It's a huge advantage. Wireshark cannot do that for you. The triggers and actions that we talked about, generating alerts, sending email alerts and recording calls on a certain trigger. Wireshark does not give that to you. You see that we also support industry standard codecs, like the codecs listed here. Wireshark, again, does not give you a lot of those codecs. We monitor fax calls. So if you want to monitor fax and actually extract fax images, we can do that. Wireshark cannot do that. On the next slide, we show you even more advantages because we really want to hit this home. Matt was mentioning air traffic management. So like he said, air traffic management there's a new standard in air traffic management called ED 137, and it's basically telling you how to implement voice over IP for making calls between a pilot in an airplane and a ground station, or a ground station and another ground station. And PacketScan gives you complete analysis of that type of traffic. You can get the voice quality for each push to talk session, the squelch session, and so on and so forth. So if you're familiar with air traffic management, PacketScan gives you a lot of capability there. The last two bullets here. So because we're giving you hardware, we give you a lot of capacity there, right? So we can monitor up to 20,000 simultaneous calls, full duplex bidirectional with PacketScan, because we're giving you the hardware, and so we can keep up with high density traffic, whereas Wireshark, it's software only, and you don't have that option. Finally, you can capture for an infinite duration. We've set up PacketScan such that it can kind of write to hard disk in a circular buffer and write to memory in a circular buffer, so you can just capture indefinitely. And yeah, you can basically capture for infinite duration. So Wireshark, on the other hand, it gives you limited capturing ability. You'll eventually fill up the memory. In PacketScan, you can specify how much memory to use when you're capturing packets. Again, think high density. You're capturing hundreds of thousands, millions of packets. Wireshark kind of just stores it all in memory, and then when the memory gets too full, it kind of crashes on you. We've designed PacketScan so that won't happen. So again, I don't want to bash Wireshark or anything. I like Wireshark too, but when it comes to telephony applications, when it comes to monitoring voice over IP, PacketScan is really the best solution out there on the market. It gives you everything that you really could possibly want. So at this point, I'm gonna hand it back to Matt and
Okay.
he will then hand it off to Sanjeev and make some comments about NetSurveyorWEB, which is our central database that we've alluded to. So Matt, thank you.
Yeah, thank you.
Feel free to take it back.
Thank you, Vikram. Thank you very much. You did an excellent job explaining PacketScan HD capabilities, and just showing us a little bit about some of the advanced features of that product. Just a quick note before I hand this over to Sanjeev. As we talked about, Vikram mentioned, and I had mentioned previously, as your packet scans are deployed, if you have multi-locations or multiple locations where you'd like to be capturing, or if you even have a single location where you want to capture, a complementary solution product that GL has is this database product called NetSurveyorWEB. So as these capture probes are monitoring all of the capabilities that Vikram showed you, those are available at the PacketScan, at the interface of PacketScan. All of that information, all of that traffic can be streamed basically to a database for storage, for long-term archiving, and for data mining. And you'll see that there are, with this NetSurveyorWEB, the applications are extensive in what you can do with the data mining, the trend analysis, even anything from a single call investigation to overall network investigation. So with that, I'd like to hand it to Sanjeev, who can give us a brief on NetSurveyorWEB. Sanjeev?
Yeah, thanks, Matt. Thanks for introduction. From here, we are going to continue about our next important application, which is a NetSurveyorWEB, which is a surveillance application. So as Matt mentioned, like if we would like to analyze all the data which are captured from the different probe locations into a single from a single point. So wherein we can use this NetSurveyorWEB. So it is a web-based client which accesses the data from the database using a web server, and provides a lot of capabilities, like we can do the in-depth analysis of the CDRs or call, and we can have a we can do this key performance, understand this key performance indicators, which mainly at the network level, and also we can do some alerts and send these alerts to the trigger and send these alerts to the different users. Okay. As it is a web-based applications, so it provides like capability to have multiple user access, and even admin he can configure and provide the different access or views to different kind of users, and he can restrict certain features, or so that they will be allowed to view only those particular kind of information. So this is what is standard type of features which will be available in all of the web-based applications. This is the main screen, like how our NetSurveyorWEB looks like upon logging into it. So you can see here, as I mentioned, based on the users, you'll be able to see the login, log data. So here, for the Matt Yost, so he is logged in and he is able to see all these data. So here you can see mainly 4 tabs. One is the data, report tabs, alarms, and the users. Users is what I explained in the previous slide, which is about controlling how or providing the access to the different users. So mainly in this data tab, it is similar like what we see these complete call detail information in the PDA, what Vikram explained in our previous slides. So we can see here all the logical calls, so displayed one by one. So here it is very similar, or it provides all the informations what we saw in the PDA about each logical calls. With along with this, what we can do is we can do a lot of filtering on the CDR, I can select based on the time. Say, for example, I want to see all the CDRs of yesterday's, today, or last past 1 week, or like last 1 month. So I can do this powerful filtering based on the time. And along with that, I can do a quick search, if I want to look into the CDRs from the particular probe location, or a particular IP address, or particular calling number or call number. So even I can do this or look into that particular data using this quick search. Uh, and what we can do is like here you could see this VoIP. So as mentioned, our probe will be deployed in a different locations. One probe will be monitoring our TDM applications, TDM traffic, or another probe will be monitoring a VoIP traffic, or another probe which is mainly monitoring all these wireless protocols. So here we provide a drop down wherein we can select a protocol category, and from then we could see the CDRs which belongs to those type of protocol or the calls. So along with this also we can have when we click on the particular call, we see all the complete details, or we can dig into the complete detailed information of the call. For example, I can see here how the call is being traversed, from which IP address or during what time, and what is the delay between each messages exchanged. And upon clicking on particular messages, I can see the complete hex, or the complete detail of that message exchange between these caller and callee. And on the right side you can see this complete information about this call, which can be categorized into like signaling and the traffic part. Like signaling, it provides a lot of informations like calling, call number, and when the call is established, and what is the duration of the call, and whether that call is successful or a failure, and all other informations. And also it provides the details about the traffic, east and west traffic, and what is the quality of that traffic, and what is there any issues, or what is the QoS. It provides the mean opinion score and all other the jitter and delay statistics. On the bottom we could see the how small event summary, like how the event is traversed. Okay, in our next slide we have one more important feature which can be used. Like we can record the traffic or voice traffic at the probe location, and we can send it to the database. And in the database we can select a particular call, and if it has a voice, and we can play and download that voice file. This is the very important feature which can be used to do this analysis, or the lawful interception. And next is like reports. Reports here mainly it is all about the entire network or the entire probe information, like how it is behaving, or what is the we can use this key performance indicators to measure this entire network. Like here, for example, you can see on the left top corner, we have a KPI called call success ratio. So here it is going to show us how many calls have been answered and how many have been failed over a period. I can have this time filter for a day, week, or a month. So these are very important in analyzing the network or understanding this or detecting any troubleshooting any issues in the our deployed network. And
one thing I'll add to that, Sanjeev, just you may be mentioning it, but these key performance indicators, very powerful. We out of the box, we give you some basic ones, basic KPIs, but we allow you through some very simple configuring to come up with your own KPIs, and your KPI may be different than another customer's KPI. So you have full flexibility. We will help you with some of the details if need be, but you can dream up a lot of different KPIs, key performance indicators, that may be relevant to you and your network. So we have full flexibility there. We have full customization for that.
Yeah, as Matt mentioned, user can define his own KPIs. We provide that interface to define the queries and come up with his own KPIs. So here we have mentioned different KPIs like duration, which is mainly used in case of analyzing this billing or coming up with the different features for the particular subscribers. In the next slide, we have some more important KPIs, mainly in case of air traffic monitoring solutions, like wherein this quality of score, like MOS score, how it is being distributed over a period or between the number of calls. So along with that, packet loss and this SCT count, and what are the failure causes if the calls are failed, and what are the major reasons and how those failure causes are being distributed different among the calls. So we can have a lot of KPIs based on the customer requirement. Okay, so some more KPIs which are being deployed currently in one of the customers, like which they will configure this like alerts, and they'll be sent the reports on the daily basis. So they wanted to monitor, or they wanted the information like how many inbound or outbound calls have been happened during a week or during a day, like such informations, or even like how the call duration is being distributed among these different calls, like how 30 seconds, or is there any long duration calls or short duration. So they wanted to analyze, so they have used our NetSurveyorWEB application to configure these KPIs and get the results. So like as we have in our Probe application, even we provide this alarms and notifications, like we can set certain alarms, say for example, if any certain calls whose MOS score is getting lowered, so we can set certain kind of alarms, and we can when that alarm is triggered, we can alert the different users in like by sending a mail, or we can do the, if they are monitoring at the screen, they will be given this visual alarms, or it can be logged to a file and extracted as a PDF and sent to the different users by using a mail. So these are the our all the capabilities of our NetSurveyorWEB application. So here till now I mentioned like it is a NetSurveyorWEB application. So now we have come up with the two versions of NetSurveyorWEB, which is same in all entire all the features, and only the difference is the capability or the data handling of data. So the reason we have come up is like not all these customers will be having these probes deployed in the different locations. They want to monitor probe on a single system on the laptop, or they just want to have details of that single probe location. So to help them, so we have come up with a NetSurveyorWEB Lite, which is able to run on the same probe, and no need to have this huge cumbersome database server running on a different location. So we can run with our probe application, and it provides the same features as I explained in the previous slides, like all the KPIs or analyzing the digging into the details of the calls. So it provides all the features. The only difference is, like, it is intended for the low volume or the single standalone probe applications. So this is the major difference between this NetSurveyorWEB and the NetSurveyorWEB Lite.
Okay. All right. Well, thank you, Sanjeev. Thank you very much. You did an excellent job of explaining the NetSurveyorWEB solution that we have, and that last slide that we showed you is a relatively new thing that we're offering here at GL, and that's that NetSurveyorWEB Lite. And as Sanjeev mentioned, we saw a need to provide a NetSurveyorWEB Lite sort of as a it has a lot of capabilities, all of the same capabilities that the regular NetSurveyorWEB does, but can be deployed maybe at a single location. So a lot of customers may want to deploy at a single location, and they don't have multiple capture probes sitting out across a large geographical area. So NetSurveyorWEB Lite is a better solution for that on multiple levels, including price. So thank you all for joining us today. Now we have some time here. I know we've run up against the top of the hour again, but we will stick around. If anybody has questions, we will have an open forum here, and we can talk about things. We can get into a little deeper, or and so forth. So Sanjeev K, do you have any questions that have been submitted?
No, nobody has raised any questions, but we can answer a few of the questions, like can you share some of the real-time deployments of PacketScan and the NetSurveyorWEB?
Sure. So they were slightly touched on during the presentation here, but we've got many deployments of these products, countless PacketScans and quite a few NetSurveyorWEB deployments. Customers are doing different things, some of which we're not sure exactly what they're up to, but a couple pretty common ones are contact centers and call centers. So a particular customer in mind here has multiple agents, call center agents, 100 call center agents sitting there, and they have a VoIP network, and GL is monitoring all inbound and outbound calls to understand what's going on, giving them statistics based on the who's calling, what area codes are calling, all of these types of things. They have some very specific needs, how many busy calls they get, and they also have some traditional T1s that we're monitoring as well as the IP side. So we're giving them these key performance indicators that the NetSurveyorWEB provides, and this particular customer's only interface to our product is basically an email that gets sent out automatically by NetSurveyorWEB on a daily basis. So all of this is running behind the scenes. All of the packet scans in the NetSurveyorWEB database and these triggers and so forth are running behind the scenes, and we're producing a daily report for this customer. and that report comes right to their inbox in Outlook, basically their email inbox. And it's an email with an attachment that gives the previous day's statistics. And those have been customized to be exactly how they want to see them, what statistics they want to see, how they want to see them, what graphs they want to show. And we've done that, and that is their interface to the NetSurveyor. So that's one deployment. There are other, another one that comes to mind is a customer is using this for wireless fraud detection. So
yes, Matt. Yeah, it can be used for this fraud SIMs, which will be used to bypass these international calls. So we can record the voice, and any customers, he can do his analysis based on his algorithms to detect these fraud-based SIM boxes. Or it can be used for this lawful interceptions from any government organizations to do this lawful interceptions.
right, so there's a fraud application here that we've used some of. So there's a wide variety of them, including truly surveillance type applications. Where we're recording who's calling who, phone numbers are calling which phone numbers, IP addresses. We have all of those capabilities to filter out, to trigger based on different things of interest, we'll say. And then we can even, as we mentioned, record the call. And one thing of note is that these calls are getting recorded. The CDRs are being created, WAV files are getting created. Third-party applications, third-party algorithms can be used on those recorded files. So voice detection comes to mind at first. Other things like that. So sometimes we're the front end of a bigger system. So we're the front end right at the interface, capturing the calls, getting statistics on the calls, and then other people are mining them for their specific applications. So that's some of our deployments.
Yeah, Matt, let me just jump in here with another application would be 911 call centers. So, in next generation 911, it's transitioning to voice over IP. So you can call into a 911 call center. You can also text the call center. You can send, media. You can send photos and so on. And it's designed to give the police and the law enforcement a more accurate picture of what's going on. As you know, 911 systems, some of them are still legacy systems, but as they upgrade to voice over IP, our PacketScan and NetSurveyorWEB can do a lot of benefit for a 911 call center. If a 911 call center is taking in thousands of calls a day, we can do some heavy analysis and see, how many of these calls, is the call quality coming in? Is the call quality coming in good? Is it coming in poor? What's the call duration? Is that call center taking in too many calls at a specific time of day? Is a nearby call center taking in less calls? We can do that analysis and really help these 911 call centers kind of load balance in terms of taking in calls and so on. So as you see more and more organizations like that transition to voice over IP, you'll start to see that PacketScan and NetSurveyorWEB can do a lot of benefit to those organizations in helping them analyze a tremendous volume of calls that could be coming in on any given day, any given hour. So that's just another application.
Yep, that's a great one that we've had.
Yeah,
thank you.
Thank you, Matt.
Yep.
Thank you, Vikram.
Yes, so we thank everybody for joining. We appreciate it. One closing note comment to make here is Very easy if you want to get a hold of GL. It's a very easy email. You can send an email. You can, if it's something specific about this webinar that you'd like to get a follow-up on, info@gl.com, info@gl.com. Very simple. You can mention, like I say, that you were on the webinar, you'd like to get a follow-up, and that will get directed to us, and we will help you with that. So I thank you, everybody. Thank you for the panelists today, Vikram and Sanjeev, thank you very much. And thank you for all attendees. We will try to have another webinar at the end of September. So please join us then. Thank you. Bye-bye.